Right, now we're starting review number 7. This corresponds to your unit number 6. Okay, it's just split up a little bit differently. So um, we're doing trigonometric functions and identities. So let's look at the properties of the graph of y equals sine x, the graph of y equals cos x, and the graph of y equals tangent x. First of all, the period of sine and of cosine is 2 pi. Might as well write that in there. The amplitude is 1. The maximum value is 1. And it occurs when x equals pi by 2. The minimum value is minus 1. And it occurs when x equals 3 pi by 2. The key points are the max, minimum, and intercepts, or where it hits the y equals x axis. We're going to draw that in a few minutes. So the key points are 0, 0, pi by 2, 1, pi, 0, 3 pi by 2, minus 1, and 2 pi, 0. The domain is, well, x can be any number in the set of real numbers. And because we have a max and a min, the y value is restricted to between negative 1 and positive 1. Okay? So, let's maybe draw some guidelines here. It's going to go, the max is 1, the minimum is minus 1. We draw each cycle of a sine function and cosine function with 5 key points. So when x is 0, let's just go 1, 2, 3, 4, 5. Okay? So when x is 0, y is 0. When x is, this is, the period of sine is 2 pi, or if you're dealing with degrees, the period is 360 degrees. Okay? So at pi by 2, it goes up to 1, right? Another key point. At pi, goes down to 0. At 3 pi by 2, goes down to negative 1. And at 2 pi, it goes back up to 0. So our sine graph looks just like that. I've just drawn one period or one cycle of the sine graph. Y equals, of the sine function, y equals sine of x. Okay, similarly, let's do the same thing for cos x. The period is 2 pi, amplitude is 1. Notice amplitude is always a positive because it measures a distance. This is the amplitude here. It goes up 1 and it goes down 1. So just up 1, down 1, up 1, down 1, just like that. The maximum value is 1, and on the cosine function, it occurs when x equals 0. Also, it occurs when x equals 2 pi. So, right? We have a maximum when x equals 0 and when x equals 2 pi. The minimum value is minus 1, and that occurs when x equals pi. Key points are, let's see, the key points are 0, 1, pi by 2, 0, pi, minus 1, 3 pi by 2, 0, and 2 pi, 1. let's just draw that. We'll draw that right now. Okay, we'll just draw some guidelines here so we know when to stop and when to start. So this is 1, this is y, x, this is minus 1. Remember, we have 5 key points to draw any cycle, so it's 1, 2, 3, 4, 5. So this is going to be pi by 2, pi, 3 pi by 2, and 2 pi. All right, so we have a maximum when x equals 0. Then it comes down to pi by 2, 0, pi negative 1, 3 pi by 2, 0, 2 pi 1. And this cosine function looks like this. So the domain is x can be any number in the set of real numbers, and again the range is restricted. Y goes between negative 1 and 1, so we have y such that negative 1 is less than or equal to y is less than or equal to 1. Y is an element of real numbers. We've already done max value and min value, so let's just draw a line there because this is a typo, and that max value and min value is for the tan function. So let's just put for y equals tan x. This is for y equals tan x, right? It should go in there, right? So the max value, well, there is no such thing as a max value on the tangent function, and I'll illustrate that to you on the graph. Minimum value does not exist. Amplitude does not exist. And unlike sine and cosine, the period of a tangent function is pi. And on the tangent function, we have some asymptotes. So that makes our domain a little bit more complicated, not just x is an element of real numbers, but it's x such that x cannot be any number where asymptotes occur, and that's at pi by 2, where plus n, any multiple of pi, because the period is pi. So let me fix that. Plus n pi, where n is an element of integers and x is an element of real numbers. Okay, so our asymptotes occur at x equals pi by 2 plus n pi, where n is an element of integers. That's negative 2, negative 1, 0, 1, 2, 3, right? And our range is y such that y is an element of real numbers. So let's sketch our tan function. Maybe I've gotten away without a ruler so far, but I think we better start using a ruler. Now let's just sketch it. We're going to have, this is our y-axis, that's our x-axis. So we're going to have a tangent to the left and a tangent to the right. Just like that. The period of the tangent function is pi, so we need 5 key points. There's our asymptotes. Okay, our asymptotes, 1, 2, and then we're going to have a point there, a point there, and a point there. So this is actually pi by 4, and this is pi by 2. This is negative pi by 4, and this is negative pi by 2. So when x is pi by 4, or 45 degrees, the tangent of 45 degrees, or pi by 4, is positive 1. The value of the tangent of pi by 4 is positive 1. The value of the tangent sorry, yeah, and the value of the tangent at negative pi by 4 is going to be negative 1. So let me just graph that just like this. And there's our tangent function. It looks exactly like this. Okay? Looks exactly like that. Okay? All right, let's do combinations and transformations of trigonometric functions. Okay? The amplitude is equal to the absolute value of A. Remember, amplitude is a distance. It's measuring a distance. So the distance between that and that would be positive 1. Even though the y value is negative 1, the absolute value of that is positive 1. The max is absolute value of A plus C, and the min is negative absolute value of A plus C. Now, this is for sine and cos, okay? This is for sine and cosine. However, for tangent, you know that amplitude does not exist, and the y max does not exist, and the y min does not exist. Why is that? Because the tangent function goes up forever and it goes down for, I guess I shouldn't say forever, I should use mathematical terminology. It goes up infinitely and it goes down infinitely. So for the tangent function, the amplitude, the y max, and the y min does not exist. So, okay. K is the number of cycles per period. The period for sine and cosine functions is 2 pi. The period for tangent functions is pi by k. The equilibrium line for both tangent, cosine, for all three of them, sine, cos, and tangent, is y equals c. Special points occur every period divided by 4. Phase shift is when d is greater than 0, it's d units to the right. And when d is less than 0, it's d units to the left. All right, we're going to sketch by fitting the axis to the curve. All right, that makes it nice. Always remember, if we want to draw our graph correctly, we need to factor out the k. So this is y equals negative 1/4 tan of 1/2 times x plus 2 pi minus 4. Always double check. 1/2 x, half of 2 pi is pi. So I think we have that correctly. If you don't factor the k, you won't get your horizontal translation or your phase shift right. Okay? So the first thing I'm going to do is draw some axes. And because it's the tangent function, I'm just going to draw it like that, sort of more in the middle than off to the side. Now, we have a phase shift of pi by 2 to the left, so this is x equals pi by 2 pi, this is 2 pi to the left, so x equals negative 2 pi, and the y is y equals negative 4. And again, we need 5 key points. Notice that there is a reflection. Just keep that in mind. So it won't, if we're reflecting, the graph will look something like this. So let's just draw it in, and then we will fill in our points, our scale appropriately. So that will go there. That will go approximately there. we need to calculate our period. Our period is equal to pi by k, because it's tangent, and that is equal to pi by a half, that equals 2 pi. So special points, this is just our rough work. Here's some more. Special points are going to occur, our period divided by 4, right? Our period is 2 pi divided by 4, every pi by 2. That's interesting. This is, well, okay. We can actually fill this in later, but since I've got it, if it's every pi by 2, this must be pi. This is negative pi by 2, and this is negative pi. Ah, no, my bad, right? So this is negative 2 pi plus 1 pi. So this should be, oh boy, I made a lot of boo-boos here. I forgot to add, I'm assuming we're on the y-axis, but we're not. Ay, 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 what have I done? What have I done? Here, let me just fix that right now. All right, let's fix that now. Let's draw our graph. Our graph is being reflected, so it's going to look somewhat like this one, but reflected over the x-axis because a is negative. I'm just going to draw that in, and now we'll get our proper scale. The vertical translation is 4 down, so this is y equals minus 4. All right. I think that looks better. Sorry. Okay. So this is negative 2 pi. Special points occur every pi by 2. So negative 2 pi is equal to negative 4 pi by 2. Now, I just need a common denominator. So negative 4 pi by 2 plus pi by 2 is equal to negative 3 pi by 2. So this is negative 3 pi by 2. And that asymptote is negative 3 pi by 2 plus pi by 2 equals minus 4 pi by 2, which is minus 2 pi. So this is minus 2 pi. I always bring it down to lowest term. I think this should be minus 2 pi by 2. I shouldn't do more than one of these in one day. So this is going to be minus pi. So this is going to be minus pi. Sorry about that. I guess I had a senior moment. I'm having more of those. Okay, minus 2 pi by 2. Now we're going lower, so we're going to have to subtract pi by 2. Minus 2, well, that was minus 4 pi by 2 because we need a common denominator. Minus pi by 2 equals minus 5 pi by 2. So this is minus 5 pi by 2. And we need to go down one more special point, right? So minus pi by 2 equals negative 6 pi by 2, and that is negative 3 pi. Okay, so there. I'm going to double check. That looks good. Negative 2 pi, negative 3 pi, and that's negative pi. Okay, now let's worry about the y value. So notice here when we went halfway between the y-axis and the asymptote, we went up 1. Well, here if we go halfway between the asymptote and our phase shift, x equals negative 2 pi, instead of going up or down 1, it's going to be up or down a quarter because the absolute value here of a is a quarter. So this is going to be negative 4 plus a quarter. So negative 4 is equal to negative 16 over 4, right? So negative 16 over 4 plus a quarter is equal to negative 15 over 4. So this is negative 15 over 4. And this one here, well, we're going to have to go negative 16 over 4 minus a quarter, and that will be negative 17 over 4. So we have a lot of rough work happening here. So that point there is negative 17 over 4. That one right there is negative 17 over 4. So that point is at negative 15 over 4, and this point is at negative 17 over 4. Oh, that's tight, huh? Okay. Let's graph this by fitting the axis to the curve. Again, remember to factor out the k. X, let's see, pi by 3 divided by a half is equal to 2 pi by 3. So it's minus 2 pi by 3 plus 3. Oh, that looks messy, right? So I'm just going to check my factoring here. 1/2 times x is a half x. 1/2 times negative 2/3 is negative pi by 3. Okay, so now we have the correct phase shift. Because this is a cosine function, this is y equals 3 for a vertical translation up 3. This is x equals 2 pi by 3. Okay, so this is being reflected. So remember, we need 1, 2, 3, 4, 5 key points. Let's just draw some guidelines here for our max and our min. I'm going to try to leave more room than I did on the other one. Okay, the amplitude here is 4. Our period is equal to 2 pi over 1/2, which is 4 pi. Our special points occur every pi, because 4 pi divided by 4, or period divided by 4, is pi. Let's see how we do here. Now this graph is being reflected, so notice amplitude is A is negative 4, but the amplitude is 4, so it's going to go up 4, so that's going to go up to 7. It's going to go down 4, so that's going to go down to minus 1. Special points occur every pi, so we're going to have to start adding pi. 2 pi over 3 plus 3 pi over 3 equals 5 pi over 3. Then we add 3 pi over 3, we get 5 pi over 3 plus 3 pi over 3 equals 8 pi by 3. 8 pi by 3 plus 3 pi by 3 equals 11 pi by 3. And then 11 pi by 3 plus 3 pi by 3 equals 14 pi by 3. And now we're in a position to label them. So 5 pi by 3, 8 pi by 3, 11 pi by 3, 14 pi by 3. Okay, so the graph of cosine is being reflected, so instead of starting up here, it's going to start down here at -1, and then it's just going to go up, up, down, down, just following the pattern of a cosine function. Okay? Sketch by fitting the axis to the curve. Here we have another scenario where we have to factor out the k. X plus pi by 8 minus 1. So let's just draw our axes. Maybe I should use a ruler. Be a good example for my students using a ruler, right? We're going to draw some guidelines. Okay, so it's not being reflected, so sine when it's not being reflected looks like this. And then we can fit our axis to this curve, right? So this is y equals -1, and it's going up 2, so -1 plus 2 is 1. -1 minus 2 is -3. And let's see, our period is equal to 2 pi divided by k, which is pi. Our special points will occur at every pi by 4. Now, this axis here is x equals minus pi by 8. So we'll be adding our special points to minus pi by 8. Minus pi by 8 plus pi by 4 is equivalent to 2 pi by 8. We need a common denominator. 2 pi by 8 equals pi by 8. So this is pi by 8. Pi by 8 plus 2 pi by 8 is equal to 3 pi by 8. It's 3 pi by 8. 3 pi by 8 plus 2 pi by 8 equals 5 pi by 8. So this is going to be 5 pi by 8. And if I add another 2 pi to that, that will just be 7 pi by 8. And I think that's complete. We labeled our axes. X equals -pi/8. I couldn't fit it down there, so I just put it up there. Our horizontal axis is y equals -1. Our max goes to 1. Our min goes to -3. And pi by 8, 3 pi by 8. It all looks good. Okay. Let's do a few examples of application problems using sine and cos. The water depth in a harbor is 21 meters high at high tide and 11 meters at low tide. One cycle is completed approximately every 12 hours. So our period, that's telling you your period is equal to 12. Now, because this is an application problem, do not approach your graphs like we do fitting axis to the curve. We have to show where the height is 0. Okay, so let's just draw some axes here. Before I write an equation, I'm going to draw the graph first because I find that much easier. I just find that much easier. So let's do that first. I didn't have to go that far. So this is going to be time. And I'm going to we'll do this time, let's see, draw after low tide. So 24 hours, that means they want 2 cycles, and it's after low tide. Okay, so I'm going to put time in hours after low tide. Time in hours after low tide. Okay, so we're going to have quite a few special points here. We're going to need, what, 4 times 2 is 8. That's going to, why don't we just go like this? 1, 2, 3, 4, 5, 6, 7, 8, and a few extra just in case. So we're going to need three guidelines. The low tide one, we'll need the equilibrium line, and the high tide guideline. I'll just do the best I can. We don't have a grid, so. Okay. So they tell us high tide is at 21 meters. So this is h of t in meters. This is time in hours after low tide, because they're going to want an equation after low tide. Okay, our low tide is 11, so what do you think our equilibrium line is going to be at? Well, 21 plus 11 divided by 2 is 16. 1 plus 11 divided by 2 is 16, because that's 32 divided by 2 is 16. I'm just going to white that out to not cause confusion with our graph. Okay, if the period is 12 hours, special points occur every period divided by 4, and that's 3. So this is going to be time 0. This will be height 0 here, right? And this is 3, 6, 9, 12, 15, 18, plus 3 is 21, 24. And they only wanted it for 2 cycles. So draw a graph of the function for 24 hours after low tide. Okay, so they're starting at low tide, and then it's going up to there, down to there, down to there, up to there, up to there, down to there. It looks like that. So let's now graph this. We know that our
Good morning. Please excuse this interruption just before the lunch hour. I did want to correct an announcement that was read during the morning announcements. It's regarding cafeteria
let's just
service.
ignore that.
There is
I just don't know if you can hear me.
today and tomorrow. Tomorrow, Thursday, June 14th, will be the last day for cafeteria service. So once again, there is cafeteria service opened today and tomorrow. Thank you.
Okay, so let's get back to business here. we need to, what is A? Our amplitude is, let's see, A equals 21 minus 11 divided by 2, and that is going to be 5. But that's our amplitude, right? That's a positive value. Our amplitude is this. Our max minus our min divided by 2 equals 5. But because this is reflected, normally cosine starts at a maximum. They don't tell us which function to use, so I'm going to use the cosine function because it's easier. Normally cosine starts up there, but it's a reflection. So they want depth as a function of time, so let's change that to depth. So depth as a function of time is equal to minus 5 cosine. Now we have to calculate our k value. Our period, you know that period equals 2 pi over k. Let's do the rough work down here. Period equals 2 pi over k. Now, our period is 12 equals 2 pi over k. We can solve for k. Multiply both sides by k. We get this. So k is equal to 2 pi over 12, which is pi by 6. So this is going to be pi by 6. There's no phase shift, so it'll be time. And our equilibrium line is 16, so it's plus 16. If we wanted a sine function, well, sine usually starts there, so I could write dt equals 5 sine. K is pi by 6. We have a phase shift of 3 to the right, so that's t minus 3 plus 16. Okay, both of them will get you to where you want to go. Estimate the depth of the water at 17 hours. Well, it's 3 hours. The first one is 14 hours. This is 17 hours. So it's 3 hours. So we're just going to plug in a 3 for t. So for part C, this is the answer to A. This is the answer to B, right? So for part C, we're just going to go d of 3 equals minus 5 cos of pi by 6 times 3 plus 16. So that's going to be minus 5 cos pi by 6 times 3, which is 3 pi by 6 or pi by 2. Well, what's the cos of 90 degrees? Well, if you forget what that is, you could punch it in your calculator because you know, but cos of pi by 2, we're landing up there at 90 degrees. This is 0, comma 1, and cos of 90 degrees, remember, is equal to x over r, which is 0 over 1 equals 0. So that's negative 5 times 0 is 0, and that is 16. The depth is 16 meters at 1400 hours. Okay, let's keep going. A Ferris wheel question. A Ferris wheel has a radius of 10, and that must be meters, and rotates at the rate of 1 revolution every 48 seconds. So the period equals 48 seconds. And our special points then occur every 48 divided by 4, and that is every 12 seconds. Okay. It starts at the bottom, and it's a radius of 10, and so it's going up as high as 22, because that means the diameter is 20. So the lowest height is 2, maximum height is 22. They start at the bottom of the ride. All right, so I'm gonna graph it first, because I think the graph really helps us find the rest of the information. So let's do part C first. And so again, don't graph application problems by fixing the axis to the curve. We have to draw it this way. We have to show where our height is above 0, etc., etc. So we can't just jump into our phase shift and our equilibrium line like we did up there. This is different. Okay, application problems are different. So again, we'll have the minimum point on the graph. I'm just drawing guidelines. We'll have an equilibrium line. We'll have a maximum. So they want height as a function of time, and this is going to be in meters. And the horizontal will be time in seconds. And you start your ride at the bottom after
Mr. Doe, please call
low point.
1525. Mr. Doe, if you're in the building, please call 1525. Thank you.
Okay, so again, it's for 2 cycles, so we're going to need 8 more points. 1, 2, okay. 1, 2, I'm wondering if that's going to be too tight. 1, 2, 3, I'm going to try going like this. 1, 2, 3, 4, 5, 6, 7, 8. It might interfere a little bit with their scale, but I think we can work with it. Now the bottom of the ride is 2. The radius is 10, so it goes up to the halfway point, which is 12. Plus 10 is 22. All right, special points every 12 seconds. So this is 0, 12, 24, 36, 48, 60, 72, plus 12 is 84, and that's going to be 96, okay? All right, we're starting at the low point, so here goes up, goes up, goes up, comes down, goes up, goes up, goes up, comes down. Alright, I think we've got the graph in good shape. So, determine, let's do A, the function. Well, if we use a cosine function, let's see, our A is 10, and it's reflected, right, because normally cosine starts at the max, but it's starting at the bottom, so y, h of t, I think they called it height, right, equals minus 10. We have to calculate the k value. Period equals 2 pi over k, right? So 48 equals 2 pi over k. Cross multiply, 48k equals 2 pi. K equals 2 pi over 48, and that equals pi by 24. So this is cos pi by 24.
Please come to the main office, please.
T, no phase shift, and the equilibrium line is plus 12. Now we could have fun when using the sine function, minus 10 sine pi by 24. The only difference is we have a phase shift to the right of 12. Right, sine normally is there at the origin, or at when the x value is 0, right? So it got shifted to the right 12, so that's minus 12. Part B, determine your height above the ground in 2.5 minutes. Now, this equation is in seconds. So 2.5 minutes is equal to we're going to have to convert to seconds. So 2.5 times 60 seconds per minute is equal to 150. So let's calculate our height at 150 is equal to negative 10 cos pi by 24 of 150, right? At 150 plus 12. Now, this will reduce to negative 10 cos pi by 24. Uh-oh. 150 over 24 over 24 reduces to 5 pi by 4 plus 12. Let's find a coterminal angle to make that more easier to work with. So 5 pi by 4 minus 8 pi by 4 is equal to 17 pi by 4, not low enough. To 17 pi by 4 minus 8 pi by 4, right? Because this is a 2 pi, right? So I'm just finding a coterminal angle. This is 9 pi by 4, still too big. 9 pi by 4 minus 8 pi by 4 is equal to pi by 4. Now this one is easier to work with. Notice these are all coterminal angles. That's a 7, and they all have the same trig ratio. So that's why I can replace this with equals negative 10 cos pi by 4 plus 12. Because the cos of 25 pi by 4 equals the cos of pi by 4. Now the cosine of pi by 4, that corresponds to 45, 45 triangle, special triangle, 1, 1 root 2. Cos of this is 1 over root 2, or rationalize the denominator, that's root 2 over 2. So this is equal to, negative 10 times root 2 over 2 plus 12. We'll get a common denominator. Oh no, this is going to be negative 5 root 2 plus 12. So, I just noticed I'm not writing conclusion sentences. We have to do that. So therefore, the height is negative 5 root 2 plus 12 meters. Here, I better write our concluding statement. Why don't I do that up here? Woo! You'll have more room on the exam. Therefore, the depth is 16 meters. Okay? Whew! Almost done. Let's do some trig identities. You should memorize all the trig, all the primary, the basic trigonometric identities, Pythagorean identities. So they are The quotient identities are tan theta equals sine theta over cos theta. Cotan theta equals cos theta over sine theta. The Pythagorean identities, there's three of them. Sine squared x plus cos squared x equals 1. Tan squared x plus 1 equals secant squared x. And 1 plus cotan squared x equals cosecant squared x. Just commit those to memories. Make your life easier on the exam. I'm just double checking. Reciprocal identities, cosecant theta, you can call it an angle theta or x, equals 1 over sine theta. Secant theta equals 1 over cos theta. And tan theta equals, cotan theta is equal to cos 1 over tan theta, which is cosine theta over sine theta. Okay, those are the ones you are using to prove trig identities. Okay, so remember when we're proving trig identities, separate left side from right side, always. Okay, so what should we start with? Well, left side equals sine theta over 1 plus cos theta. Like they're both in terms of sine and cos, so we can't simplify that much. But what we could do is multiply this by the conjugate, and you'll see what happens. Oh, so just a little trick. When you see a 1 plus cos or a 1 plus sine, multiply it by its conjugate. So that's times 1 minus, you're actually multiplying by 1. You're multiplying the numerator by the conjugate of the denominator, and you're multiplying the denominator by the conjugate of the denominator. So this is equal to sine theta times 1 minus cos theta all over 1 plus cos. I'm going to actually FOIL it out. So this is going to be 1 minus cos theta plus cos theta is 0. Remember to FOIL, minus cos squared theta. Now, notice that 1 minus cos squared theta, like if I move that to the other side, that would equal sine squared theta. So now I have sine theta times 1 minus cos theta all over sine squared theta. Don't skip any steps because you'll lose marks for skipping. So theta goes into sine theta once, sine theta goes into sine squared theta sine times, sine theta times. It's 1 minus cos theta over sine theta. And that is equal to the right side. Okay. Okay, let's look at this guy. Left side is equal to 1 plus 2 sine x cos x. So I know the trick to this. We have to get that sine x plus cos x to the top. So I'm thinking, if I could change this and factor it and divide out the sine x plus cos x, I could end up with that. So notice I'm using this trigonometric identity. 1 is equal to sine squared x plus cos squared x, but I'm going to write it like this. I'm going to go sine squared x plus 2 sine x cos x plus cos squared x all over sine x plus cos x. Notice I didn't drop the 1 because sine squared x plus cos squared x equals 1. And there's my 2 sine x cos x. So now this is a perfect trinomial square. It's easy to factor, right? This is equal to sine x plus cos x times sine x plus cos x all over sine x plus cos x. Well, that will divide out, and I am left with sine x plus cos x, and that equals the right side. So just remember to practice. That's the only way you're going to get good at trigonometric identities. So take care, pat yourself on the shoulder. You just got through review number 7, and in review number 8 we'll actually combine discrete functions with financial problem solving. Bye bye.